Well, just a couple of weeks ago, before Asheville, North Carolina ceased to exist as we know it due to the storm, the NCI, National Comfort Institute Summit took place up there. And I was up there. I've been a member of NCI for almost 2 years now. And I really like what they're doing. They're really big on testing, especially airflow, total capacity, as well as combustion analysis. And I've always been aligned with that. They have a really good business model for small contractors, medium-sized contractors to adopt with a lot of flexibility, but it just has some processes and templates in place so that you also can do testing and high performance work. But first of all, before I proceed with my truck rant, I want to thank my new sponsor, and that's Brunswick Supply House. Brunswick Supply House is a national HVAC distributor that just so happens to be located in my backyard here in Brunswick County, North Carolina. But they sell all the brands that I am passionate about. Santa Fe Dehumidifiers, Haven IAQ. They're a Bosch distributor. And so check them out. Even if you're out of state, even if you're out of the area, they got great pricing. They will ship to you. All right, getting back to the truck rant. What are we going to talk about today? What I was talking about today was the need for us to really give a second look at what measurements that we're taking on a typical service call or preventative maintenance. One of the things that the NCI instructors said that resonated with me was, don't take readings unless you're going to do something with that data. And I talked about this a little bit in a recent article that I wrote that was featured in HVAC Tactical Magazine, the summer 2024 edition. The title of the article is HVAC Moneyball, Can It Work? And one of the things I talked about was that we've got to really be as efficient as we can and take readings that actually matter. And so one reading kind of jumped out at me, and I've been thinking about this a lot. And why do we take amperage readings on compressors and fan motors? Now, obviously, we want to make sure that amps are staying below the full load amps or the run load amps, depending if you're working on a compressor or a motor or fan motor. But really, how often do you see an amperage reading that makes you pause and say, wait a minute, I've got to investigate further? A lot of times, especially in residential, I think technicians are taking amperage reading and they're just logging it out. And maybe they're not even looking at what the nameplate amperage is on a motor. They're just taking that reading and they're moving on. Why are we wasting our technicians' time when their time could be spent getting other relevant readings? For example, how many contractors out there are taking amp readings and it's just kind of a yup check and they're not even checking static pressure? See, if I had to choose between the two, static pressure would win every single time. But even then, when we take static pressure, if it reads 0.4, 0.5, 0.8, what do we do with it? Like, there needs to be a threshold on the low and the high side in which our technician has to investigate further. And by investigating further, we need to start doing some static pressure mapping. Maybe do something with the true flow grid that tells us where exactly we're picking up that high static pressure. But really low static pressure is just as bad. That could be an indicator of something internal to the air handler, like a blower wheel or an internal coil that's stopped up, something that's not allowing the external static pressure to take place. So again, technicians need to know what to look for when they take those readings, and not just take readings just to take them. So most of the time, business owners know about KPIs, key performance indicators. There are KPIs when it comes to performance indicators of HVAC systems. And if you take all these readings and you don't do anything with them, then it's sort of like a business owner that has this amazing field management software and it gives them all these reports, but he or she actually never reads them, and he or she never makes any changes on the business or any adjustments to the business based on those reports. It's the same thing when we give our technician a long list of things to check and then we don't do anything about those, or we don't train the technician to have conversations with the customer based on those readings. And so for me, I think especially in residential, but I'll go as far as to say even in light commercial, amperage readings are almost a waste of time. If that motor is overamping, that motor is probably cutting off on a thermal overload. And it doesn't really have to be that hot outside for that motor. If it's overamping, it will cut off on a thermal overload even if it's cold in the same environment. So you're going to know whether that motor is overamping. If you're going to check something electrical, I would much rather you check power factor. because power factor transcends all sizes of motors, all voltages. Obviously, if you have something three-phase versus like an ECM motor, what you're looking for is a little bit different, but you can still take power factor on the entire unit, power coming in. You can set thresholds. If our power factor is below 0.94, we need to take a look at capacitors more. We need to check motors. Maybe we need to do a megohm test on our motors. If it's 0.94 or whatever your threshold is and higher, then we move on. And that way the technician is spending the time in the right places. They're not wasting time investigating things that are actually normal, and they're not wasting your money and wasting opportunities by not investigating further on issues that could actually lead to lucrative sales and repairs and that sort of thing. Let's talk about superheat and subcooling. People take those readings all the time. They think they're actually doing a good, thorough job when they're taking superheat and subcooling. And look, I applaud you. It shows that you're trying. But what do you do with those numbers? How do you know if that reading is normal, especially on a fixed orifice metering device? And let's face it, there's still plenty of those around. Superheat can be all over the place. Depending on indoor wet bulb and outdoor temperature, you could have 5 degrees of superheat. You can have 27 degrees of superheat. And in either case, the system could be operating correctly. Or in either case, the system could be improperly charged or another factor. So unless your technician is going to go to the next step and say, okay, well, here is my superheat, let me compare it to a charging chart, then it really doesn't matter. You might as well not even take it. And for that reason, I really like being able to take screenshots and measure quick, because I can log all that information. In fact, MeasureQuick now has a dashboard where you can see all your readings all on one screen. So you can actually just take a screenshot of that. That way you document it. Obviously, you can run the MeasureQuick reports if you're going that route. But what I like about MeasureQuick is that it factors in. As long as you put all your probes in and you give it the right information, then MeasureQuick's going to tell you whether that superheat and subcooling is normal or not. Because if we just go with one static number, that technician is going to make the wrong call a lot, and we're going to have a lot of improperly functioning systems out there. The other thing about MeasureQuick, what it does is tell you what your delivered capacity is, and I am actually starting to use that more than a lot of other readings, just because that's where the rubber meets the road. If I have a nominal 3-ton system and I'm putting out 26,000 total BTUs, then I know something's wrong. Well, obviously, in order to get delivered capacity, we need to get airflow, and so that's why I'm using the TrueFlow grid from the Energy Conservatory a lot. But if we're not taking that data with the objective of doing something with it, figuring out whether there's a problem, figuring out if we need to turn that into a sale or not, as long as it's ethical, then I think we need to be using data for that reason. Just collecting checklists, and those checklists become repetitive over time. Anybody that's spent time in the field as a technician just knows that those checklists become mundane. You don't even think about the numbers. You're just in automatic mode, and your brain kind of turns off. And a lot of times technicians, when their brains turn off, they overlook things that otherwise would have been obvious if they were engaged. And so the only way to keep them engaged is to have them take readings that they actually have to make a diagnosis based on. And they're just not taking it just to log readings. So the whole point of this truck rant is to inspire us to do a little bit better about how to make our checklists for our technicians work a little bit more effectively, to make sure that we're not taking readings unless we're going to do something with them, to make sure our technicians know the importance of the readings that we are asking them to take. So I'd like to know what you think. Do you feel like the traditional readings that we take, like amperage, superheat, and subcooling, do you think that they're still relevant? What do you do with them so that they maintain their relevancy? Or do you think that we need to make a change? And how would you make that change? So as always, thanks for watching, and be safe.